Good evening guys to all of you on this wonderful platform that is BYJU'S Exam Prep. So guys, as we are going in this monsoon crash course, and here guys, yesterday we have seen some questions on simple stress and strain, and today we are going to move to the next topic, pure bending and pure torsion. Yes, we were left behind some questions, so I am having those questions at the end, as the name of this session is related to bending and torsion. So first we will do the questions from bending and torsion. After that we will come back to the questions of the simple stresses and strains. And guys, do like and share the session. I want more and more people to join in this session, because this is the LTQ learn through question. We are going to learn the concept with the questions. Yes, Midun, good evening. Ravi Gupta, good evening. Nikhil, good evening dear. Piyush, good evening. So we are starting the session guys now. So without wasting the time, so today's topic is pure bending and pure torsion. Why I have taken this question as a one? Because one question generally is coming from these two topics. Okay, so we are starting this. Madhu Amshi, hello dear, namaskar. So guys, this is some detail about me. Those who are watching me for the first time, I'm having 10 plus years of experience, have written many research and review papers. These are my areas of interest, and strength of material is the subject going on. Yes guys, let us move on. So guys, you know this rankers monsoon crash course, this we are going to discuss 6 technical subjects, and they are covering major part of your syllabus, and plus we are also going to discuss about mathematics that Rakesh sir would be taking, and aptitude is already going on the Sundays. So the complete preparation will be there for you guys in this series. This is of LTQ. Abhishek, good evening dear. Sandeep, good evening dear. So now we are starting the session. So guys, one more information is there. Abhinav Negi sir would be taking a workshop. That workshop is for the GATE aspirants. That will be there on 3rd of July at 12:30 p.m. Okay, those who want to join this, they can register for this. This is the free workshop. So guys, now let us see the very first question. And as you know, the questions are from bending and torsion. So this is the first question in front of you. So guys, here we are going to see all the concept through the questions, and these questions are all the new questions. These questions I have not taken up before in the YouTube session. So guys, they are going to be new questions for you, and you are going to learn each and every concept from which GATE and ESC are asking. Okay, yes Sachin, good evening. So this is the first question. Find out the maximum stress produced in a round steel bar 60 mm in diameter and 10 meter long due to its own weight when it is simply supported at its end. Steel weight is 75,000 Newton per meter cube. I will be giving you the hint for that. Yes, thanks Abhishek. So my dear, we are going to have a steel bar like this, and it is simply supported. Okay, it is simply supported, and you need to consider it as a simply supported beam. So when you will consider it as a simply supported beam, and they are saying that consider the self weight. Self weight is always considered as UDL, my dear. So when you are considering this UDL, let us say the load intensity of this is W kilonewton per meter. So my dear, or you can take in Newton also, then W Newton per meter. So my dear, first of all, you know that whenever we need to find out they are asking maximum stress developed. So you know that my dear, what kind of stresses would be coming because of this load. This will be having some kind of bending to be happen. So you need to find out the bending stresses. Okay, and for that we need the maximum value of bending moment. So you know, for UDL, if we know the W value, then my dear, we are going to have this kind of bending moment diagram. Everybody would be knowing that this type of BMD is coming. Can you tell me what is this value? Can you tell me what is this value? Let us see how many of you are aware of that. Yes guys, so I am taking some wonderful great questions guys for you. Can you tell me what is this value, maximum bending moment? Yes, anybody? Sir, please change color of pen. Okay, I am using now yellow color. Is it fine, Shivam Tiwari? So can you tell me what would be the value of this maximum bending moment if this is the bending moment diagram? Yes, anybody? Very good, Bhavya. This is going to be WL square upon 8. That we will see how to find out in SFD BMD. Okay, but still if you want to find out, I am telling you, if this is W and in length L, the total load is going to be W into L. So my dear, because of symmetry, here support reaction will be WL by 2. Here support reaction also will be coming out to WL by 2. And if you want to find out the maximum bending moment, which is obviously because of symmetry is coming at the center, which is at L by 2 distance from here and there. So you can write down, if this is point A, this is point B, this is point C. You can find out the maximum bending moment, that is at C. So that is going to be equals to the support reaction, that is, let us say VA into L by 2, minus, you know that the entire load can be considered as W into L at the center, and that is acting at a distance of L by 2. This is the case. This is what you are finding out to get the support reactions. And my dear, when you are writing in this way, it is minus W into L by 2. Is it clear? You know the equation is coming like VA into X minus WX square by 2. This is how the equation is coming, and I am directly writing the value in this way, and VA is known to us, that is WL by 2. So when you will be writing it at L by 2, you will get WL square by 8. So my dear, this is the maximum bending moment. You can see load is given 75,000 Newton per meter cube. So my dear, if you want to find out the total load, that is small w into L, that is going to be, they have given this 75,000 Newton per meter cube. You will write 75,000 Newton per meter cube. You need to multiply with the area and length. Area for this circular bar is 75,000 into pi by 4 d square into L. Diameter and length are given to us, guys. Diameter and length are given to us. Okay, Nikhil Bhatia is saying the answer is B. What about others, guys? So guys, this type of question you can see in the GATE examination, soon they will be coming. So guys, that's why I am preparing you for all the levels of question. This is a level which have never been asked in GATE. Now upcoming questions are of the level which are coming in GATE again and again. Okay, so everything we have covered. Nikhil is saying B, Piyush is saying B, Bhavya is saying B. So yes, what about others? Madhuvamshi, Ravi Gupta is saying C. Okay, what about others? Yes. So my dear, in that way you will be finding out the maximum bending moment, but you need to find out the bending stresses. Bending stress is M Y max upon INA. That is the case. And you know bending moment, you already know the maximum bending moment. Y maximum is diameter by 2 divided by pi by, it is going to be 64 d ki power 4. Okay. So solving, you can find out the bending stress value. So Midun is also saying B. Okay guys, so yes, the answer when you will be getting it, the B, the value is 124.9 Newton per mm square. This is going to be the answer. Okay, very good Shivam Tiwari. You can see one thing, guys, length is 10 meter, diameter is 60 mm. So in that way you can put the value and get the answer, and your answer would be B for this. Very good. So guys, this is the second question. So my dear, okay, we will see this question. As you can see, the things are given to us. They are saying that a copper wire having diameter D as 3 mm. Actually, there is a copper wire. This is the copper wire, which is having a length of L. And they are saying that is bent into a circle. You can see, this is the wire which is bent into a circle, guys. When it is bent into a circle and held with the ends just touching as shown in the figure, if the maximum permissible strain in the copper is 0.0024. So my dear, they have given the maximum strain. Maximum strain they have given as 0.0024. The shortest length of the wire that can be used. So my dear, when strain is going to be maximum, the length is going to be minimum, because you know it is delta by L. So when this is maximum, this is going to be minimum for sure. So my dear, you need to find out this minimum value of length which can do this, and if you want to do that, you must be knowing that this length is converting into this. Everybody know what is the circumference of the circle? It is 2 pi r. So let us assume the radius of this is r. So my dear, you know that L is nothing but 2 pi r. You know it is nothing but pi into d. Guys, they are very wonderful question. In the starting, I am taking this question. In between, there are those types also which are related to previous year's question. Not exactly, but yes, similar type of question have been asked. So I am taking all the types. So this is L is 2 pi r, this is pi into d. Okay, that d is obviously this when I'm talking about this radius, this is the diameter. Okay, this is length actually. So my dear, you know very well that whenever we are talking about the bending stresses, the equation is m upon I sigma b upon y E upon r. Is it clear? You are using this, and you also know that epsilon is coming out to be y by r. That also we have seen. Epsilon is coming out to be y upon r. So my dear, when epsilon is coming about y by r, you know that whenever we are talking about this, length is given to us. Sorry, length need to be find out. This is pi d, this is 2 pi r. So now I have given you hint. I would like you to solve this question, and you need to find out the minimum length of the wire which can be used. Just try this, guys. I want you to solve this. Here you just need to use this concept what I have mentioned, that epsilon is y by r, and you know epsilon is nothing but delta L by L. It is given to you, that is what is epsilon max. Using this you can find out. Just try it, guys. Just try this. Yes, guys. What would be the answer for this? Midun, Shivam, Sandeep Reddy, Piyush, Bhavya. Solve it. You know epsilon maximum is 0.0024, and that can be written as y upon r. And my dear, whenever we are talking about y, you know that this diameter is already given to us as 3 mm. So if you take the neutral fiber, what would be the value of y max? Y max is going to be 1.5 mm. Y max only will be giving you the maximum strain. Okay, Nikhil is saying the answer to be 3.92. Yes, Nikhil, very good, very good. So guys, if you see this from here, you can write R is L by 2 pi. Just put this value there, my dear. You can see Y is already, you know that this is 3 mm by 2 is 1.5 mm, and R is L by 2 pi. You know epsilon maximum is given to us as 0.0024. Equate it to 0.0024. You will get the value of L, that is your answer. Madhuvamshi is saying 3.9, Piyush is saying 3.9, very good. Nikhil is saying 3.9, बहुत ही बढ़िया. Sandeep Reddy, Shivam Tiwari, very good. Midun, the answer will be coming out to be 3.9. Yes, it is correct, 3.925. Piyush ji have given the correct answer, up to 2 digit, 3 digit, very good. बहुत ही बढ़िया. Bhavya, yes, your answer is also correct. Wonderful, dear. Very good, Bhavya. Wonderful, dear. Great. So guys, are you getting? This is a new type of question. Don't worry, now we are coming to the normal types also. So these were the new types of question, and you can have these questions in the upcoming GATE examination. Shall we move on now? Yes. The next question, guys. The next question. I am giving you the hint for that. Guys, just like and share the session. I have taken a lot of questions for you today. I am having 30 questions, out of which we are going to solve in the class 27. 3 would be your homework question. Very good, Iman Kalita. बहुत ही बढ़िया, शानदार, dear. Wonderful, dear. So 2 cantilever beams of same length and cross-sectional dimensions carry the same load at their free tip. Okay, there are 2 cantilever beams. One cantilever is this, other cantilever is this. They are having the load on their tip like this, and they are saying their length is same, cross-sectional area is same, and also the loads are same. The first beam made of steel. So this is the beam made up of steel, and this is the beam made up of aluminium. And they are saying the value of E for steel is 3 times that of aluminium. So E of steel is 3 times E of aluminium. And you need to find out the ratio of stress in the steel to the aluminium. That is what you need to answer. This is a question where many students are going to be confused. Yes. बहुत ही बढ़िया. Let us see how many of you give the right answer. Yes, guys. Yes, solve it, solve it. You solve it. I am just sharing the sessions to the other students also. Yes, guys, solve it. Wonderful. Wonderful, guys. Yes, Piyush is saying A means 1. Bhavya is saying 1. Nikhil is saying D. Okay, guys. Okay. So all of you are saying D to be the answer. So guys, I would like to say your answer is correct, because whenever we are defining the bending stress, it is coming out to be M divided by INA into Y. And my dear, this bending stress is not at all a function of E. So when you will be finding out the bending stress in steel by bending stress of aluminium, the ratio will be coming out to be 1. Yes, very good, guys. Wonderful. बहुत ही बढ़िया. So the answer for this would be coming out to be 1. As I already told you, stresses are not depending on the Young's modulus. Is it clear? Dear, stresses are always depending on the load you are applying and the cross section. Whenever we are talking about E, yes, it is going to give us a picture of the resistance. Yes, it's true. So whenever we are talking about the stress, we are always saying that it is going to be independent of E. Is it clear? Wonderful, guys. Imon, Kalita, wonderful. So 21 ME, 23 Sam, I feel you got it. There is some mistake done by you. Let us move further. So guys, next question is question number 4. And this is again a wonderful question, guys. This is the question which is a good one because the geometry have been changed. It has been seen whenever gate question is coming, they are giving always either rectangular cross section or square cross section or circular cross section. But my dear, here I am taking semicircle. So this type of question have never been there in the gate examination. This would be a new one. Why we don't, dear, I already told you, Piyush ji, that whenever we are talking about E by R sigma B by Y, this is used whenever radius of curvature is known to us. I told you when I taught you that there are 3 equations, A is equals to B, B is equals to C. So we are using this sigma by Y is equals to E by R whenever radius of curvature is known to us. Is it clear? Yes. So my dear, this is a beam. The beam as shown in the figure below subjected to pure bending by couple M naught. If the cross section is a semicircle, then the ratio of the maximum tensile stress to the maximum compressive stress. You can see this is a sagging moment. So in the top fiber we will have compression, in the bottom fiber we will be having the tension. So my dear, I am going to make this in front of you like this. This is the circular section. You know, at top we will have compression, at bottom we will have tension. And the neutral axis would be there. You know the centroid for semicircle, it is at a distance of 4r by 3 pi. You can also write it as 2d by 3 pi. Yes, it is 4r by 3 pi. So my dear, if this is 4r by 3 pi, what is this? This is r minus 4r by 3 pi. And you know, my dear, sigma is directly proportional to y. So if you want to write down the stress, they are asking about tensile and compressive. Tensile maximum will be coming at the bottom fiber, compressive maximum will be coming at the top fiber. So sigma tensile but a sigma compressive is sigma bottom to the sigma top. So it is going to be y bottom, y top. So this is y bottom, this is y top. So I am giving you guys all the data which are required. I am helping you with this type of data which you must remember from your engineering mechanics knowledge. Yes, solve this, guys. Let us see how many of you give the right answer. Nikhil is saying 0.74. Piyush ji, Imon Kalita, Sam, Nikhil Bhatia, Madhu Vamshi, Midhun. What would be the answer, guys? Yes. Please tell me the answer, guys. I have given you the data. I have given you all the things. Just solve it. Solve it, guys. Very good. Bhavya is saying 0.737. Yes, thanks Nikhil. Yes. So 2 students have given the answer. So this is Y bottom, Y top. So if you want to write down the stress, tensile by stress compressive, it is the ratio of Y bottom, that is 4R by 3 pi divided by R minus 4R by 3 pi. Is it or is it opposite to this? Opposite to this. Yes. What would be the answer? It is coming out to be point. Okay, Midun, Madhuvamshi also have given the answer. Imon Kalita also have given the answer. So guys, sigma tensile by sigma compressive, it is coming out to be 0.74. Very good guys, 0.74. Madhuvamshi, I have already shared yesterday's class PDF in the Telegram channel, and today's class PDF I will be just sharing after the class. So don't worry about that. Yesterday I have shared late night, but today I will share soon, just after the class. Yes. So guys, this is a wonderful question. In a rectangular beam, if the depth is doubled, the maximum bending stress will reduce by a factor. Yes. If we are going to increase the depth to double, then bending stress will reduce by what factor? That is the question. You can imagine that if we have a cross section with B width and D depth. Now he is saying if width is same and depth is doubled, what would be the effect on the bending stress? You know that bending stress is given as M by Z NA. So bending stress is inversely proportional to ZNA. Is it clear guys? And everybody would be aware that for rectangular section, what is ZNA? What is ZNA? What is ZNA? It is going to be BD square by 6. So my dear, if depth is becoming 2 times, what would be the effect on the stress? That you need to tell. My dear, you can write sigma B for 1 case, sigma B for 2 case, will be Z for second case, Z for 1 case. So you need to write width is same, D2 square by 6, width is same, D1 square by 6. Just tell me the answer guys. Everything I have done for you guys, you just need to put the values and get the answer. This is how the CTQ happens. So this is the way, the type of question which they are asking. Piyush ji is saying C, Bhavya is saying C, Nikhil Bhatia is saying C4. Very good. What about others? Wonderful guys. Imon Kalita is saying C, Midun is saying C. Wonderful, wonderful. And yes, the answer will be coming out to be C, because when you will put B by 6 will cancel out. 2D का square divided by D का square. The answer is 4. बहुत ही बेहतरीन. Next question guys. This is entirely new question. You can see this is given to you and it is mentioned locomotive axle 250 mm in diameter without board bearing is subjected to transverse load as shown in the figure. Determine the maximum bending stress induced in the axle. So whenever they give beam type of thing, my dear, very good Shivam Tiwari, whenever they give beam type of thing, it is for sure that you will be getting bending stress to be maximum, where you will be having bending moment to be maximum. Where you will be having bending moment to be maximum. And my dear, if you want to see the bending moment to be maximum, symmetry is there. So because of symmetry, if this is point A, this is point B, this is point C, this is point D, then my dear, the support reaction at B and C are going to be equal because of symmetry. So this is going to be VB, this is going to be VC. And we will be having VB is equals to VC, that is 115 kilonewton for the symmetry purpose. And if you are getting these values, my dear, at point B, the bending moment is going to be maximum for sure. Why? Because if you are going to find out the bending moment at section 1-1, you will be saying that bending moment at section 1-1 is, that is going to be W into X. And it is going to create hogging. Okay, there is no need to go for plus minus. If you are going for bending moment at section 2-2, you can see this is creating in this way, this is creating in that way. So you will write W into X minus VB into X minus the distance is 340 mm. So obviously, my dear, this is negative sign, so it is going to reduce something. So guys, obviously, if you want to find out the maximum bending moment here, that is going to be W into 340. Because after this point, bending moment will start decreasing. Here also, if you come from this side, after this point, bending moment will start decreasing. So maximum bending moment is W into 340. Is it clear? I am going by very much common sense type of thing. I am not assuming that you will be able to make the BMD of this. Yes. So guys, W into 340 is the maximum bending moment, and you need to find out the maximum bending stress. So maximum bending stress is M maximum upon ZNA. As you know, radius of curvature is not given to us, so you will be using this, and you need to find out the bending stress maximum. To find out ZNA, you can see, okay, it is mentioned a locomotive axle 250 mm in diameter without bearing. Okay, diameter is given to you, it means it is circular one. Yes, so find out the answer, guys. Yes, Bhavya is saying 25.49, Piyush is saying 25.49, Nikhil is saying 25.49. Yes, and guys, I would like to tell you that the answer is correct, because when you will find out ZNA, it will be pi d cube by 16. So when you will be finding out the maximum bending stress, you will be getting the value to be equals to 25.49. This is the answer. So guys, please tell me, what is the level of question according to you? Is it fine or not? They are the new type of question, and I am covering each and every type. Whenever you will sit in exam, that is my promise to you guys, that none of the question in the exam will be out of these types. Dear, for that you need not to go, because board bearing, they are the types of bearing used for the railway tracks. So that you need not to worry about, okay? Because you need not to worry about the railway engineering. That is not the part of mechanical. And civil, they will be studying in the railway part of that, okay? Yes. Fine, guys. This is the question. This is also a new type. This is easy but new type. This is the type, my dear, when you are going to get the radius of curvature. Whenever radius of curvature is given to us, we are using sigma b by y is E by R. Just start solving. Yes. So a wire of 2 mm diameter, there is a wire of 2 mm diameter is wound round a circular shaft of 2 meter diameter. So there is a circular shaft of 2 meter diameter. On this wire is going to be wound like this. Like this. Obviously, this will be the neutral axis of this wire. So you know the distance up to neutral fiber is R. R is the radius of neutral fiber. Thanks, guys. Thanks. So you can see E is given to us, wire diameter is given to us, radius is given to us. So whenever radius of curvature is known to us, this small r is known to us. So my dear, then you will be saying that bending stress is E into Y divided by R. You need to find out maximum bending stress, so you will be taking Y max. Just you need to put the value 1 into 10 to the power 5. Into Y max, you know that this distance will be Y max. If the dia of wire is 2 mm, it is going to be 1 mm divided by radius of curvature is going to be, yes, 2 meter diameter. So it is going to be 1000 plus 1. Yes. Piyush ji is saying 50. Okay. What about others? Is it coming out to be 50 or 100? 100 is the answer. You can see na here 1001, here 10 to the power 5. The answer will be 100 Newton per mm square. Wonderful, guys. Sir, why can't we apply torsional analysis to rectangular shaft? Dear, actually, whenever we are talking about the rectangular shafts, for them, the results coming are different. Like whenever we are going for the bending analysis, it is valid for all the cross section. But when we are talking about the torsion analysis, then my dear, for rectangular shafts, for square shaft, the stress distributions are coming out to be different. So they are not coming same as that of the circular one. So that's why we are going for different analysis. But in bending, they are giving the same result. So when they give the same result, we will be using that. Next question, guys. This is once again on the same concept. So guys, this is my promise. If you are covering these classes, none of the exam which is having strength of material syllabus will be having a question out of these type. वेरी गुड सचिन गौतम, इमोन कलिता, बहुत बढ़िया मधुवंशी, बहुत ही बढ़िया भव्या, राम प्रकाश, यू गोट इट, यस. एंड गाइस, टू गेट दीज PDF, ज्वाइन माई टेलीग्राम चैनल मैकेनिकल बाय धीरज सरदाना. When a steel wire is bent around a cylindrical drum of radius 32 centimeter, the maximum normal strain in micron produced in the steel wire diameter is 1/16 centimeter. It is mentioned that. So you can see radius of the drum is 32 and the dia of wire is 1/16 centimeter. So you know that the bending stress is going to be equals to E into Y max upon R. So my dear, whenever we are talking about this, we need not to find out stress. We need to find out strain. Strain is Y max by R. So E value is not at all required. What is Y max? Y max is nothing but small d by 2 divided by R is mentioned to us. Solve it and get the answer, guys. Solve it and get the answer. And you need to give the answer in microns. Mind it, the units also. And guys, just like and share the session. Abhi number kam hai. Yes, just like and share the session, guys. Such wonderful question, where you will find out, guys. Yes, yes, yes. What is the answer, guys? Okay, wonderful. Bhavya, answer needs to be given in microns. They are asking the answer in microns. So my dear, I feel the answer have been given by Bhavya is 976.56. The same is Nikhil's answer. Madhuvamshi, your answer is not correct. Okay, in microns it would be more only, na? When you will convert centimeter into millimeter, multiply by 10. When you find mm to microns, it is multiplied by 1000. So the answer is 976.56. Okay, that microns. बहुत ही बढ़िया, गजब guys, बहुत ही बढ़िया, शानदार. Let us move to the next question. Next question is question number 9. Okay. So guys, right now bending questions are going on. After that we have torsion question. Then we have simple stresses questions. Okay. And guys, every day we are having 1 to 2 topics. Up to Saturday, we will complete all the topics of SOM. On Sunday, you have a live test with me only on the BYJU'S Exam Prep app. And the toppers would be getting the prizes in that. Okay, top 3 students would be getting the prizes for that. But for that, we want a good number there, and whatever you are studying here, that is going to be the part of test series, that test. Okay, and the same we will be repeating for fluid mechanics in the next weekend. Okay, so this is going to be like that. Wonderful, Sachin Gautam, but your answer is in not microns. I feel you are giving answer in some other units. Okay, an unspecified pure bending moment is used, means M is unknown to us. Bend an aluminium rod of radius 2.5 mm. So there is an aluminium rod of radius 2.5 mm. Elastically bent into circular ring of radius 2 meter. Capital R is 2 meter. If the same bending moment is used to bend elastically a copper rod of radius 2 mm, then the radius of the resulting ring, that you need to answer. And here E is given to us. You know, my dear, that whenever we are talking about the bending stress, it is coming out to be E Y by R. Okay, so my dear, they have given you the E, they have given you the small r by which Y can also be found out, and they are asking you the capital R. Okay, Bhavya is saying the answer to be D. Okay, let us see what about others. Okay, what about others? You know the equation is M by I, E by R. They are not talking about the bending stress, they are talking about the bending moment. So you can write M to be E I by R. They are saying that bending moment is same. Same means you can equate M1 is equals to M2. You can write E1 I1 by R1, E2 I2 by R2. And you know that in case of bending, I is about neutral axis, pi by 64 d ki power 4. So my dear, you just need to put the values here. If R is 2.5, D will be 5 mm. And here D2 will be 4 mm. So just put the values and equate the things. You will be getting the value of R2. So guys, those students who were asking at that time, sir, why we are not using E by R? So have you seen the application when we are using E by R concept? Yes, you must be able to understand now. So some of you have already given the answer. They are saying 2.808. And I would like to tell you guys, I feel you are giving the value of diameter. Please check it. They are asking the radius. Very good, Bhavya have given the right answer. The answer would be 1.404. The answer would be 1.404. Very good guys. बहुत ही बढ़िया. Wonderful guys, wonderful. So everybody is clear. Shall we move on to the next question? Are you clear about this? इस बात पे लाइक शेयर कुछ तो कर दो यार, बढ़े आगे. Shall we move on? Very good Piyush, very good Piyush. Yes, Midun, Nikhil, got your mistake or not? Ravi Gupta. Everybody. Okay, let us see the question number 10th now. Question number 10th, guys, is saying along the length of beam, the extensional as well as compressive strains have been recorded at top level. So you know that if we have any beam, let us say, so you know we are not knowing about the cross section, but they are saying the bending stresses and bending strains. So you very well know that the bending strain distribution is coming like this. Bending strain distribution is coming like this. We know that. And they are saying that they have found out the bending strain at the top. They have found out the bending strain at the top and 150 mm below it across the depth as this and this. The total depth of the beam is 240. So they are saying that total depth of the beam is 240. This is 240. Okay, and they are saying that they have found out this value and this value. As you can see, both values are having the same signs. So obviously it will be coming here, 150 mm below. because otherwise one should be tensile, other should be compressive. But they have given the same sign convention for both. It means they both have the same sign convention, means both are on the same side. So my dear, let us assume this distance to be x. And you need to find out if A1 and A2 are the areas of the cross section under tension and compression, the ratios of A1 and A2 are. Yes, Ravi Gupta is giving the answer to be C. Okay, so let us check it. So my dear, first of all, what you need to find out, actually you are already given this strain at this fiber and this fiber. First of all, you need to work over that what is this distance x. Because if we will get this distance x, we will get this distance also. Then we can very easily find out whatever is asked from us. Dear Bhavya, they have not said that this is a rectangular cross section. In rectangular cross section, the y top and y bottom are same. In the symmetrical cross section, y top and y bottom are same. They have not mentioned that cross section is symmetrical. But they have given you the strain values. You can see the strain values are 4 and 1. It should be either 4 and -1. Then it is fine. One is at top, second would be at bottom. So they are saying both as positive. So both are on the same side only. Yes, we are going to use the similar triangle as Piyush ji is saying. This is one triangle. This is one triangle. And this is another triangle. So my dear, if you want to use this, you know that epsilon top is known to us. Here also epsilon is known to us. You will write epsilon top by x. And epsilon top by x, epsilon by x minus 150. So my dear, you just need to find out the x value. Epsilon top is 4 into 10 to the power minus 6. Epsilon is 1 into 10 to the power minus 6. Find out the value of x, then I will tell you what you need to do. Yes, I am giving you the hint for that then. Solve it, solve it, solve it. Give me the value of x, then we will move further. Yes, guys. Wonderful, wonderful, guys. X is coming out to be 200. बहुत ही बढ़िया. So my dear, when you will be using this, you will get x is equals to 200. It simply means that this distance is 200 and this distance is 40. So my dear, you know that stress is given as load bate area and it is also written as E into epsilon. So you can write 1 by A is inversely proportional to strain. So my dear, when you know the strains of top and bottom fiber, because if you know the strain at this fiber, you can find out strain at this fiber, because this distance is 200, this distance is 40. So my dear, you can write one thing, epsilon top by epsilon bottom is, distance of top by distance of bottom is, this is 200, this is 40. And my dear, this will give you the strain at bottom fiber. And then you can see epsilon is 1 by A. So area of top but area of bottom will be strain at bottom by strain at top. So this will give you the ratio of AT by AB. Is it clear? Find it out, guys. What better than this you can have? Guys, this type of question never happened, never came in any of the exam. Because now they are asking new types of question. So I am going to prepare you for those types of question as well. The question which have already been asked, that type also we are covering, and we are covering with these new types also. So whatever the test series you give, whatever the exam you give, whatever be that level of question is, you must be having the similar question in the class before the exam. That is what we are thinking of. Yes, guys. Solve it, guys, solve it. बोलो भाई निखिल कहाँ गए, पीयूष जी, भव्या, Ravi Gupta, Midun. So guys, you can see the distance is 240. This will be 5. So my dear, if top by bottom is 5, bottom by top is 1 by 5. So area of top by area of bottom is 1 by 5 and area of bottom by area of top they have asked. This is going to be 5. So the answer is going to be 5. Okay. Okay. Yes, this is how we are going to solve it. Fine Piyush, thanks for that. Very good Nikhil, बहुत ही बढ़िया. Guys, we have just solved 1/3 of the questions. 2/3 are still there. Very good Midun, very good Madhuvamshi. So guys, the 11th question is there. The ratio of moment carrying capacity of a steel beam of circular section 40 mm dia to that of square section. Yes, they are asking you the moment carrying capacity. You know that moment carrying capacity is directly proportional to Z. So they are saying you to find out the moment carrying capacity of circle to the square. So it is going to be Z of circle to the Z of square. Z of circle is nothing but, you know that, pi by 32 d की power cube. Square is a cube by 6. Is it clear for everyone, guys? Solve it and get the answer. Thanks Nikhil for your wonderful words. Yes. Very good Iman Kalita, wonderful dear. Now answer about this question, guys. This is the level of question which is coming in engineering services and in GATE for 1 mark. Okay. This is a good question for ESC point of view. And GATE 1 mark. Yes, guys. So, yes. Wonderful, wonderful. I feel Bhavya have answered it. So, Bhavya is saying the answer to be D. बहुत बढ़िया. Iman Kalita, is it your answer for 11th question or 10th? So he is saying the answer to be D. What about others? I want all of you to solve at least this level of questions. This type of things are very common in GATE. Madhuvamshi is saying D. Bhavya is saying D. बहुत ही बढ़िया, शानदार guys. Very good. Midun is saying 4.71. Dear, just see the options. Piyush ji is saying D. Midun is saying D. बहुत ही बढ़िया guys. So the answer for this question is going to be D. You will be getting 3 pi by 2. When you will be putting the values, you can see diameter is given to you, A is given to you. So putting the values, you will get 3 pi by 2. Question number 12. Last question on bending. Then we will go for torsion questions. Last question for bending, then we will go for torsion question. A beam is loaded by couples at each of its ends. You can see these are the couples. The beam of steel and its cross section is shown. The maximum tensile stress in the beam in MPa. You can see distance of top fiber, distance of bottom fiber are given. My dear, I would like to tell you this is the level of GATE. This type of questions are coming in GATE. Okay, right now. But you can see out of 12 question, every question was of different type. So out of 12, 2 to 3 types are very common which are coming in GATE. Rest are new types question you will be having in GATE. So you need to find out maximum tensile stress. You know this is sagging, in the top compression, in the bottom tension. So you need to find out the tensile stress. So sigma tensile you need to find out. So you know sigma tensile, when you are going to find out, it is going to be M Y upon INA, or you can write M upon Z NA. So my dear, bending moment is given to you 5 kilonewton meter. ZNA you need to find out. You know that you can also go for I by Y. So Y is going to be this distance 40.3. So solve it guys and give me the answer. Solve it guys and give me the answer. Okay, you have already given. Fine. So Bhavya is saying, Nikhil is saying B, Bhavya is saying C. Okay, let me check it. Solve it guys properly. I feel one of you is wrong, one is correct. So answer is correct. Actually, dear, both of you have given the answer. One have given for tensile, one have given for compressive. You just see Y of top is 84.7, Y for bottom is 40.3. So this 55 MPa will be nothing but the compressive stress. 26.2 is nothing but the tensile stress. Is it clear guys for everyone? Is it clear for everyone? बहुत ही बढ़िया. So Nikhil's, your answer is correct. Now Bhavya have also given the answer. Venkatesh, बहुत ही बढ़िया. The answer is B for this. बहुत ही बढ़िया. Sachin, बहुत ही बढ़िया. Sachin Gautam, बहुत ही बढ़िया. 26.16. The exact value Sachin is giving. Very good dear. And guys, today you know I am going to give you 3 questions as homework also. Very good Piyush ji, बहुत ही बढ़िया. Shandar, Lajawab. And guys, if any one of you want to have handwritten notes of strength of material, join my Telegram channel Mechanical by Dheeraj Sardana. You will get handwritten notes of strength of material, engineering, mechanics and all other subjects. Okay, so you can get the help from that also. I have also shared previous year's question of mechanical, civil. Soon I am going to share AXI questions and PI questions also. Okay, so you will get PYQs also there. Very good Madhu Vamshi. Next question guys is question number 13. Now we are starting with the torsion topic. Bending questions are over, torsion questions are started. Okay. Yes, solve it guys. The question is saying an aluminium tube of outer diameter 40 mm. I am writing out the data. And they are saying the inner diameter to be 30 mm. The length is given as 460 mm. When the tube is subjected to a torque of 650 Newton meter, the angle of twist is found to be 3.5 degree. You know that angle of twist is TL by GJ. But they are saying it 3.5 degree. So convert them into radians. Calculate the maximum shear strain. Calculate the maximum shear strain. Yes guys. Apply gamma by R is theta by L. Okay, you know when derivation is done, I told you R theta is equals to L gamma. Apply this relation, you can find out gamma because all other things are given, but theta should be in radian. Mind it. Let us see how many of you solve this. Yes, Venkatesh, Madhu Vamshi, Imon Kalita, Nikhil Bhatia, Sachin Gautam, Piyush ji, Bhavya. Wonderful guys. Yes. You guys are doing great. Solve it guys, waiting for your answer. Okay, Bhavya is saying the answer to be A. What about others? Guys, this is also a type which have never come in GATE, but this type have already been there in ISRO and DRDO. Okay. Midun, very good. Piyush ji. Okay, so all are saying that answer is going to be A for this. And I agree with you guys, the answer is coming out to be 0.0026. बहुत ही शानदार यार, बहुत ही बढ़िया. So guys, just imagine the similar type of questions would be there in exam. You guys are going to do wonder there. Okay, you are going to get excellent, even complete marks in strength of material. Sure, Nikhil, I will share. I will share. Even actually, I was thinking of more than that. Okay, and this is surprise after 2 days. Actually, tomorrow only, me and Rakesh sir would be coming for a generic session for HPCL. Okay, there are many, you can say, good announcements are there for you guys. Those who are preparing for HPCL, DRDO, for them also a number of announcements would be there. So guys, the propeller shaft of a steamship has to transmit the power of 7500 kilowatts at 240 RPM. 240 RPM. The shaft has an internal diameter of 150 mm. Calculate the minimum external diameter. Minimum external diameter if the shearing stress in the shaft is to be limited to 160 Newton per mm square. Yes, so you need to find out the DO minimum, and you know that first of all power is 2 pi NT by 60. This will give you the value of torque. Then you know that tau max is T by ZP. Yes, dear Venkatesh, I am talking about the same. So tomorrow at 11 PM, me and Rakesh sir would be there in front of you. And there we will discuss about the level of HPCL. And also we will be telling you about how to prepare for that. And for that, how we are going to help you. Everything would be there. Okay guys, solve this. And you know what is ZP actually? ZP is J by R. It is going to be pi by 32. D0 4 minus Di 4 divided by D0 by 2. Solve this guys. You need to find out the D0 value. Tau max is already given to us. Ravi Gupta is saying the answer to be B. Okay. What about others? What about others? Yes. Actually, answers are given in very close range. Yes, Nikhil. Generally in GATE that much close are not given. Yes guys. So here obviously the calculations mistakes are more for such kind of question. Here actually you need to go for an approximation. Like for such cases you go for Newton-Raphson. Okay. That type of question is actually there are very less chances. So you have seen such kind of approximation in numerical methods. So for such cases, if that kind of questions comes, we need to go for such things. And don't worry guys, this type of questions will not be coming where you are using this. Okay. So when you will be solving this with the approximation of Newton-Raphson, the answer will be coming out to be 226.7. So D0 is coming out to be 226.7 mm. Okay. But you can leave this question because such type of things are not there. But I wanted to show you the level. In test series, you can get this type of question. So you always need to avoid these questions and do them at the last only. Okay. Whenever you see such kind of things. Fine guys, let us see the 15th question. A hollow shaft and a solid shaft constructed on the same material have the same length and the same outer radius. The inner radius of the hollow shaft is 0.6 r. Assume that both the shafts are subjected to same torque. The ratio of maximum shear stress in the hollow shaft to that of the solid shaft. Very good, Madhu Vamshi. Okay, you don't know. Okay. So Piyushji, don't worry. Actually, that is the part of Newton-Raphson method. Okay. So I will be sharing you that calculation part. Okay, in the Telegram channel with this PDF. Okay, then if you do not understand, just tell me there. I will teach you that in the next class. Okay, because right now if I go for it, the questions will remain uncompleted. Okay, so I will be definitely teaching you that in the form of a short or anything. I will share the solution with you on the Telegram channel. Yes, Nikhil Bhatia, that's why I have taken this question. Actually, The same question have been asked from the Nikhil in the Bark interview. So that's why that kind of thing I have discussed here. So a hollow shaft and a solid shaft constructed on the same material have the same length, the same outer radius. So there is a solid shaft and there is a hollow shaft. There is a hollow shaft. Yes. So Imon Kalita, Ravi Gupta, you also have the same issue in the previous question. If yes, we will be taking the Newton-Raphson calculation also in the class. So guys, they are giving the both same radius. The inner radius of the hollow shaft is 0.6 r. So you can see inner radius is small r and capital radius is capital R. This is 0.6. Okay, so this is given for this hollow shaft. And overall, if you see, the diameters are same. So capital R of solid and capital R of hollow are also equal. You need to find out the shear stress. You know that shear stress in solid shaft, shear stress in hollow will be T by ZP of solid divided by T by ZP of hollow. And my dear, they have also given, very good, Venkatesh, Piyush ji and Nikhil Bhatia and Bhavya. Yes, Piyush, actually you just message me anywhere, either on YouTube or Telegram, I will share you the link. If you search mechanical by Dheeraj Sardana, the channel will come. So guys, assuming that both the shafts are subjected to the same torque, so torque will get cancelled out. You will get the ratio of ZP of hollow to the ZP of solid. So when we are talking about ZP of hollow, so my dear, you know that pi by 16, it is coming out to be for hollow, 1 minus k to the power 4 into d ka cube divided by pi by 16 d ka cube. This is solid, this is outer of hollow. You know, outer of hollow and ds are same. K is small r by capital R is 0.6. Just put the value and get the answer, guys. Venkatesh, join my Telegram channel, Mechanical by Dheeraj Sardana. I feel Nikhil Bhatia is sharing that. Just join that. There you will get the PDF of this class and also many handwritten notes and all. So guys, solving this, we will be getting the answer to be 1.15. The correct answer is 1.15. Very good, guys. So the answer is 1.15. So guys, always remember, whenever you are comparing power of hollow to the power of solid, to the power of hollow, it is coming out to be torque of solid to the torque of hollow. It is coming out to be ZP of solid to the ZP of hollow. This ratio is always equal. Is it clear? Okay, Bhavya, hollow to solid पूछा है. Okay, Piyush. I will try to see what is the issue with that. So they are asking hollow to solid. Okay, then I have done it oppositely. Okay, you will take hollow to solid. That will be ZP of solid to the ZP of hollow. So my answer would be 1 by 1.15. Yes, but the answer is 1.15. That is correct. Very good, guys. Question number 16 now. Still 14 questions are left. A 50 mm diameter shaft is driven at 15 Hz by a motor delivering 35 kilowatt of power. Find the maximum shear stress in the shaft. Yes. Solve this, guys. This time they have given the frequency in Hertz. Yes, solve it. F is 15 Hertz. Solve it. First of all, you will be using 2 pi nt by 60. 2 pi nt by 60. From that, find out the torque. then tau max is 16t by pi d cube. Yes. So this is nothing but n only. Okay. So Nikhil is saying the answer is 15.13. Let me check the answer. Okay, what about others? Bhavya, okay. Bhavya is saying 9 and okay. Answer I am asking Bhavya. 15.13 MPa. Very good. So how you will calculate n from the f? In place of n they have given you the f. Yes, Nikhil, Bhavya. Very good, very good. So Minachi, Meena, Piyush ji have also given the answer. Wonderful, guys. Great. So omega is 2 pi f or 2 pi n. Okay, so that is how you can use f in place of n. Very good. So guys, the answer will be 15.13 when you will put the values. First of all, I am telling you the torque. I have already done the calculation for you. 371.16 Newton meter will be the torque. And tau max will be coming out to be 15.13 Newton per mm square. बहुत ही शानदार. Yes. Actually, whenever the frequency is in hertz, it is, you know, this is going to be in the seconds. So there is no need to divide by 60. So here, if you want to be clear, this capital N is RPM, small n is RPS. Okay, so this frequency hertz means in per second it is given. Next question, guys. This is the question from shafts in series. Shaft in series. So my dear, as I already told you, I am covering all the types. This type of question 6 to 7 times is being asked in GATE paper. So I am covering the new types as well as the old types, as well as the things which have never come in any of the exam. A shaft ABC 2.7 meter long consists of part AB and BC, length 1.5, 1.2, diameters are given, and they are saying total angle of twist. Total angle of twist is always given for the free end, that is C with respect to A, and that is given as 2.5 degrees. So you can see if this is shaft number 1, this is shaft number 2, then my dear, theta 1 plus theta 2 is theta total. Then we can write T1 L1 by G1 J1, T2 L2 by G2 J2 is equals to theta total, that is 2.5 degrees. You can convert that into radians. And what you need to find out? You need to find out the torque. If you apply method of section, guys, you will say both T1 and T2 are equal. So you can find out T very easily, L1 by G1 J1, L2 by G2 J2. Okay, so find out the value, guys. Find out the value, guys. Okay, are you talking there? Here it is mentioned na 1.5 and 1.2. Okay. Piyush sir, in combination of shaft, I have problem in taking the signs. Definitely, Piyush. I am telling you after this question. Solve this, then I am telling you. Okay. Bhavya, I feel some mistakes you have done. Your answers are correct, but not in terms of units. Answer will be C only for this question. No doubt about that. So I feel you have done some mistake. Okay, there is no mistake because the answer is in kilonewton meter. You are writing in Newton meter, they are asking in kilonewton meter. Okay? Yes, wonderful guys. So guys, do like and share the session. Still many questions are pending. Okay? So just like and share so that other student can also join it. Very good. So guys, let us see actually, like Piyush is saying that he is having some issues in applying this method of section. Dear, we are having this kind of things. Okay, these are two sign convention. So they will be mentioning that actually whenever you are given this, whenever you can see this is open at right hand side, it is mentioned it is clockwise from right hand side. And when they see, give it like this is clockwise from left hand side. So from right hand side, if you imagine a clock, revolve your finger clockwise, you will get this direction. So my dear, here the direction of this couple is given like this. And here from left hand side clockwise, you will be having this. So here the direction is given like this. So one you need to consider as positive, other you need to consider as negative. So whenever you are going to have this, you can see this are the directions here. These are the directions here. So you can take anyone as positive, anyone as negative, and there is no issue in that because in torsion question, they are never giving the answer in positive or negative ways. So sign convention actually is not going to be used here much in the questions. Is it clear? I got it, Bhavya. Don't worry. I got it. So guys, question number 18 now. This is a composite shaft. Composite shaft means the shafts in parallel. Yes, composite shaft means shafts in parallel, made up of steel tube with the inner brass, and it is bonded together as shown in the figure. The shaft is fixed at one end and subjected to a torque of 2T here. The 2T torque is acting here. Okay, and they are also saying the shear modulus of steel is G, brass is G by 2. Outer radius of the steel is 2R. The inner brass core R. Torque carried by the outer steel tube is. It is a very nice question. Just imagine that steel is bearing a torque of T1. Brass is bearing a torque of T2. You know, for parallel case, the one equation is T1 plus T2 is equals to 2T. Equation number 1. And the second equation is theta of steel is equals to theta of brass. So if I am saying steel to be 1, brass to be second, I can write theta 1 is equals to theta 2. I can write T1 L1 G1 J1 is equals to T2 L2 G2 J2. So my dear, all other things are given to us. This is equation number 2. You can find out T1 and T2 using these two equations. No issue, Madhuvamshi. For that only these sessions are. If you are feeling any weakness in them, don't worry. On this channel only there are many marathon theory sessions are there from which you can learn those topics. Okay, I have taken many marathon sessions where complete strength of material is discussed. So you can go through that once again practice previous year's question, then solve these questions also. Actually these questions are of wonderful level. That is also one thing. Okay, so use these two equations. One is T1 plus T2 is equals to 2T. Second is T1 L1 by G1 J1, T2 L2 by G2 J2. Okay, so one is for steel, second is for brass. All the things are given. The formula for J is pi by 32 d ki power 4. This is for solid. For hollow it is pi by 32. D04 minus Di4. Yes. बहुत ही बढ़िया. Yes, Bhavya, what you say? The answer. Equation 1, equation 2. I am showing you the question again, guys. The question is saying the torque carried by outer steel tube is. So they are giving the answer in terms of T. You need to find out TS actually. Bhavya is saying 15 by 8. Okay, 15 by 8 is, there is no option like that. I feel some mistakes you have done. There is no option like 15 by 8. Yes, yes. Solve it, guys, solve it. You will be able to make it. Equations are there in front of you. Nikhil is saying B, 60T by 31. Yes, very good, Nikhil. Bhavya, what about you? कामेश्वर महतो इज सेइंग बी. बहुत ही बढ़िया भाई कामेश्वर, बहुत ही बढ़िया, शानदार. हाँ भाई पीयूष जी कहाँ चले गए? मिथुन, मधुवंशी, सचिन गौतम, वेरी गुड. मीनाक्षी मीना, वेरी गुड. Calculation mistake. Yes, dear. So when you will solve it, my dear, you will get TS as 31. Okay. It is coming out to be 60T by 31. 60T by 31. 60T by 31. This is T1. And if you want to find out T2, you can find out from this. You can find out T2 as 2T minus 60T by 31. Okay, it will be coming out to be, I feel, 31 into 2, 62. 62 minus 60, 2T by 31. Okay. Very good. No issues, guys. Wonderful. I feel everybody got this question. This is what we are doing. This is shafts in parallel. If you see, my dear, we have covered all the type. Shafts in series, shafts in parallel. Okay, now let us see some other types. Question number 19. A hollow steel shaft of external diameter 100 mm. A hollow steel shaft of external diameter 100 mm. So you can say D0 is 100 mm. By looking at the options, the question seems to be very dangerous, but it is not. Inner diameter is 50 mm. It is going to be replaced by a solid shaft of diameter ds. Assume same value of polar modulus. ZP of solid, ZP of hollow. ZP of solid is going to be pi by 16 D of solid ka cube. It is going to be pi by 16. Yes, it is D0 cube, sorry, D0 4 minus Di4 divided by D0. You need to find out what? You need to find out, yes, assume the same value of polar modulus for both the diameters of the solid alloy shaft will be. Diameter of the solid shaft ds will be. That you need to answer. Ravi Gupta is saying C. What about others? All options are looking like similar. Some differences are there. Here it is square root, here it is cube root, here it is cube root, here it is square root. Pi by 16 will get cancelled out. D0 is 100, Di is 50. You just need to put the value. 100 की power 4 minus 50 की power 4 divided by 100. You need to find out ds. Yes, Midun, Piyush, Bhavya. What would be the answer? Solve it guys, solve it. बहुत ही बेहतरीन क्वेश्चंस हैं and guys already 7:20 is there the time. So I feel we are unable to solve all the question because I am having around 30 questions. Let us try for 1-2 more. Bhavya is saying D, Nikhil is saying A, Midun is saying B. So if you see Ravi is saying C, Bhavya is saying D, Nikhil is saying A, Midun is saying B. This is the perfect example of a gate question. Because whenever you solve gate question, so in gate questions, they are giving the option in such a way that if you are going to make some mistake, you will reach to the wrong option. So for different mistake, different options you are reaching. Okay. Sachin Gautam is saying C to be the answer. Yes guys, anybody else? Kameshwar Mehto is also saying C to be the answer. Yes, Nikhil, Bhavya. First of all, D is not the answer. B is not the answer. 50-50 lifeline I have done. Now answer is either A or C. Tell me what is the correct one. A or C. तो भव्या डी तो गलत है. ए और सी में से बताओ. मैंने 50-50 लाइफलाइन यूज कर दी. See where you are making the mistake. Yes. Okay. So guys, answer is A for this. Just check where you are doing the calculation mistake. The answer is A. Answer is not C, answer is A. So Sachin, Minachi Meena, Kameshwar Mehto, you have done some calculation mistakes. Okay. So let us move to guys the question number 20. Question number 20 is finding out support reaction. This is also the favorite type of GATE and ESC. This type of question have been there in both the exams a number of times. A bar PQ of diameter 40 mm, length 3 meter is long, rigid, fixed. A torque of 500 Newton meter is applied at a section of the bar 1 meter from the end P. This is 1 meter, this is 2 meter. You need to find out the torque at P and torque at Q, means support reaction at P and support reaction at Q. That you need to find out. You know that how we are assuming the direction. If they are giving the torque in this direction, we are going to assume the reaction opposite. So you know one equation is TP plus TQ is equals to T. That is 500 Newton meter. Can you tell me, can we here go for a shortcut? Do you know the shortcut? If you want to find out torque at P, what you will be doing? You know that this and this are opposite in direction. So you will first of all put plus sign. You will put the value of torque T, the distance from opposite end, the total length 3. If you want to find out TQ, you know this and this are opposite in direction. So plus sign. You know this is the torque T. The distance from opposite end is 1 divided by 3. So it is coming out to be 2T by 3 and it is coming out to be T by 3. What would be the answer now? Yes, Sachin Gautam, Minachi Meena, Kameshwar Mehto, Imon Kamita. Wonderful guys, wonderful. So the answer for this would be coming out to be A. Yes, here GJ is constant. And whenever GJ is constant, we can go for the shortcut. So we have used the shortcut guys and we reach to this solution. Is it clear for everyone, guys? Yes. Wonderful, Sachin. Question number 21. A new type of question. They have never asked about the strain energy. They have never asked about the torsional strain energy. So I would like to tell you torsional strain energy is given as T square L by Gj. Okay, so they have given you the torque, they have given you the Gj, and they have given you the length. This type of question have never been asked in GATE till now. This is a new type. So guys, if you are going for this monsoon crash course, I can guarantee your selection. Sandeep Reddy is saying the answer to be A. Okay, what about others? Okay, you are saying for previous question. Sandeep, where were you today? I feel you joined late. Yes, guys, solve this. Solve it, guys, solve it, solve it, solve it, quickly solve it. T square L by, sorry, 2 Gj आएगा. I forget. 2 Gj it is. What would be the answer, guys? Yes, Piyush, Nikhil, Bhavya. So guys, these types of series are going to make you rankers, because here you would be knowing that in which areas you need to work more, and when you find it, the areas, it is becoming easy for you to revise. Bhavya, once again, small mistake you are doing with calculations. Torque is 85 kilonewton meter. You are also getting 5.4. Okay, actually the answer coming for this is 0.54. Maybe some data mistake may be there. Maybe this G is not 4,000. Maybe this is 400 or 40,000. There may be some mistake. Okay, so 5.4 is coming, then okay, it means some data issue is there. So we will make it 5.4 because that is very easy question. So some data issues would be there. 0.54 is coming. Okay, yes, there is no need to convert. Yes, definitely it is correct only. So whenever we make some new questions, some data errors may come. Okay, so let us see the next question, guys. Question number 22. This type of question have already appeared in both ESC and GATE. So now these are the types which have already come. A bar of circular cross section of dia 100 mm is subjected to a torque of 10 kilonewton meter. The angle of twist at A is. So you know from A to B there is no torque. So theta at A and theta at B are going to be equal. So if I say this as 1, this as 2. So you can write T1 L1 by G1 J1. Torque is going to be the same. It is mentioned as 10. Solve it and get the answer, guys. So we will keep it up to this 22nd question. So rest 7 questions are homework for you. I will share the PDF just after the session. And those 7 questions, my dear, we will be solving tomorrow. Okay. So everybody know tomorrow on which topic we have the class? Tomorrow's topic is principal stresses and strains. Be ready for that. The most important topic for both the branches, mechanical and civil. So Nikhil Bhatia is saying the answer to be C. And yes, guys, the answer is correct. 1.167 degrees. Okay. Okay, before we move further, I would like to tell you that, guys, attend all the classes properly, because on the Sunday these things are going to be used. Okay, Piyush ji, I will be sharing you the topic wise schedule. So tomorrow's session will be on principal stresses and strains. Okay, so you can revise that so that tomorrow when you come, you will be able to make the questions. So guys, these sessions are going to be very useful for you. Daily 1.5 hours practice you are getting live with the faculty. That is also for free on YouTube. What else you are looking for? Okay, and those all question solutions, whatever you are getting here are authentic only. Okay, so guys, do you want that Newton-Raphson type of question? If you want, I will give you the solution of that on Telegram also. If you find any difficulty there, then definitely we can have a discussion in the live class also. So goodbye guys for this session. Thanks for joining. Do like and share the session before leaving the class. Okay, tomorrow's topic is principal stresses and strain. We will be having around 25 questions of that topic plus the 7 question remaining of today's class. So total around 30 question will be there tomorrow as well. So we are meeting tomorrow guys. Goodbye. Goodbye. Thanks for this session.